Is it true that in your mind dinosaurs have always been giant monsters with gray, stone-cold skin? Creatures that only roar and crush everything under their feet. But what if I told you that many of them were actually covered in soft feathers? That beneath that seemingly dry reptile exterior was a world full of color, warmth, and a surprising closeness to the birds flying in the sky today? For millions of years, we have misunderstood the true appearance of the creatures that once ruled the earth. And it all began with a tiny, seemingly meaningless discovery in the ancient rocks of Liaoning, China, where a chicken-sized fossil skeleton stunned the entire scientific world. Because it carried something no one ever thought dinosaurs could possess: feathers. A tiny detail, yet enough to rewrite the entire evolutionary history of birds and of dinosaurs themselves. The journey to clear the name of dinosaurs did not actually begin in Asia, but in Europe, specifically in Germany more than 150 years ago. In 2061, just 2 years after Charles Darwin published On the Origin of Species, a stone quarry worker in Solnhofen, Bavaria, accidentally discovered a strange skeleton. It was the size of a crow, with sharp teeth and a long bony tail. Yet it bore clear impressions of feathers spread on both sides. Scientists named it Archaeopteryx, meaning ancient wing. The discovery baffled the scientific community. How could a creature with teeth and a bony tail possibly fly? But that very contradiction sparked a bold hypothesis, that there must be an unknown link between birds and dinosaurs. And that was the first moment humanity suspected that the creatures dominating the sky today might carry the bloodline of dinosaurs. The Solnhofen region, where Archaeopteryx was found, was once a shallow lagoon millions of years ago. Its still, salty, oxygen-poor waters preserved dead organisms as if they were mummified in stone. These unique conditions captured every delicate detail, from bone structures to feather fringes along the wings. Archaeopteryx thus became a gemstone of paleontology, a witness between two worlds, birds and dinosaurs. Around the same time, paleontologists found other flying creatures such as pterosaurs, including the genus Germanodactylus. Though not true dinosaurs, they shared the skies of the Jurassic. Unlike birds, pterosaurs had wings made of skin membranes, not feathers, which only highlighted the special role of feathers in shaping the future of avian flight. From that small discovery in Germany, the world began a far greater search. The true origin of feathers and the secrets hidden in the skin of ancient creatures. More than a century later, the unexpected answer came from the East. In the mid-1990s, in Liaoning province, northeastern China, a group of farmers accidentally dug up slabs of stone containing small, skeletal traces. When scientists examined them, they realized they were standing before one of the most shocking discoveries of the century: the skeleton of Sinosauropteryx, a small dinosaur about 1 meter long covered with fine fuzz-like filaments. In 1996, the first images of Sinosauropteryx appeared in scientific journals, and the world of dinosaurs was never the same. At first, many doubted they were feathers, suggesting they might be collagen fibers or impressions of skin tissue. But under an electron microscope, researchers discovered melanosomes, pigment sacs identical to those in modern bird feathers, proving they were real feathers. Pigment analysis even revealed that Sinosauropteryx had brown, orange, and white banded patterns, a detail showing dinosaurs were far from the dull gray creatures we once imagined. From that moment, Liaoning became a time treasure vault of paleontology. Countless fossils were unearthed. Caudipteryx, a small dinosaur with true feathered wings on its arms and tail, though incapable of flight. Microraptor, a four-winged creature with feathers on both arms and legs, shimmering like a black-blue kite. And Yutyrannus, a fully feathered species that lived even earlier than Archaeopteryx, proving feathers appeared before dinosaurs learned to fly. And especially Yutyrannus wally, a feathered tyrant, a distant relative of T-Rex, nearly 3 meters tall and covered in thick feathers. Clear evidence that even giant dinosaurs could wear warm coats. All these extraordinary fossils were preserved thanks to Liaoning's unique environment. Millions of years ago, it was a system of lakes surrounded by active volcanoes. When volcanic ash fell, it quickly buried organisms, preventing decay and freezing every detail. Bones, skin, and even the thinnest feathers. As a result, fossils here are preserved with a delicacy matched by few places on Earth. For decades, dinosaurs were viewed as distant relatives of lizards. Slow, cold-blooded, and completely unrelated to graceful birds. But science began turning the tables. A series of discoveries forced people to reconsider. Perhaps the birds perched outside your window today are the living descendants of dinosaurs. This reversal began in the late 1960s, when American paleontologist John Ostrom discovered the skeleton of a compact creature with an upright stance, sharp claws, and long legs, named Deinonychus. Unlike the heavy dinosaurs of movies, Deinonychus was agile, quick, and showed signs of being warm-blooded. More like modern birds of prey than reptiles. It had hollow thigh bones, strong muscles, and shoulder structures strikingly similar to birds. Ostrom realized these traits couldn't be coincidence. Deinonychus is not just a dinosaur. It is a transitional step on the path to birds. That idea was treated as a joke at the time. The conservative scientific community refused to believe that the king of dinosaurs could be the ancestor of tiny birds. But Ostrom persisted. He and his student Robert Bacher ignited what came to be called the dinosaur renaissance, a movement that completely changed how humans viewed dinosaurs. Bacher said, "Dinosaurs were not stupid or sluggish. They were dynamic, intelligent, and highly adaptable." From there, everything began to fall into place like long-lost puzzle pieces. The chest structure of many theropods, the two-legged dinosaurs, was almost identical to birds: a protruding sternum for flight muscles, a light pelvis, large eye sockets, and one-way lungs, a respiratory system more efficient than that of mammals. These small details assembled together revealed a clear truth. Birds are not merely related to dinosaurs. They are dinosaurs. Evidence kept piling up. The Archaeopteryx fossil, once seen as the first bird, was reclassified. It was not a true bird, but a feathered dinosaur capable of flight. Its teeth, bony tail, and claws were all dinosaur traits. Only its feathers were a new evolutionary feature. This helped scientists realize feathers did not evolve for flight but for insulation and display, and were later repurposed for flying. The more scientists studied, the more amazing parallels they found between birds and dinosaurs. Both laid hard-shelled eggs, brooded them with body heat, and cared for their young. Some fossils from Mongolia even showed theropods curling around their nests. Exactly like birds brooding today, DNA doesn't survive long enough to compare directly, but the remnants in modern bird genes align with evolutionary models of ancient dinosaurs. Today, most scientists agree that birds are the direct descendants of theropod dinosaurs, including Velociraptor and Tyrannosaurus. In other words, dinosaurs did not fully go extinct. They transformed, shrank in size, and grew wings. If you ever thought feathers existed only to help birds fly, you might be surprised to learn. For millions of years, feathers had nothing to do with flight. They began simply as thin filaments that kept bodies warm. Imagine a small dinosaur living in chilly mornings where dew covered the ground. If it had only smooth reptilian skin, heat would escape quickly and it wouldn't stay active for long. But a layer of tiny, fluffy fibers, like a natural jacket, could trap body heat. And so feathers were born. Scientists call this stage 1 of feather evolution. Simple, hollow filaments growing randomly across the body. Gradually, over millions of years, nature upgraded them. The single filaments branched, aligned in rows, and eventually formed clusters that evolved into more complex feathers. By stage 5, we had the complete feathers of modern birds, with a central shaft, barbs, and tiny hooks weaving a surface that was light yet incredibly strong. But before true flying birds existed, there were strange creatures, half dinosaur, half bird, with feathers just enough for gliding, though not true flight. One of the most famous is Confuciusornis, discovered in China and living around 125 million years ago. Confuciusornis looked like a beta version of a bird. It had a true beak, without teeth, but still retained ancient features like claws on its wings and a tail with fan-shaped feathers. Males had long, shimmering tail feathers, likely for display rather than flight. Beneath the feathers was a light body with hollow bones and wings capable of weak flapping. It could glide from tree to tree like modern flying squirrels, not fully capable of flight but no longer earthbound. A creature standing on the boundary between land and sky. From here, scientists began intense debates. How did dinosaurs learn to fly? Two major hypotheses emerged, each sounding like rival martial arts schools. The first is the ground-up hypothesis. According to this view, the ancestors of birds were fast-running, two-legged dinosaurs like Deinonychus or Microraptor. When they chased prey or leapt from danger, feathers on their arms provided slight lift like tiny parachutes. Over millions of years, these jumps became true wing beats. Nature experimented again and again, eventually creating flight. The second school is the tree-down hypothesis. Here, small tree-dwelling dinosaurs like Yutyrannus used their feathers to glide down safely. Like flying squirrels or gliding lizards, they learned to maneuver through the air, and as muscles and feather structures improved, they eventually began to flap. The truth is likely somewhere between the two. Some species may have evolved from the ground, others from the trees. But the common link is simple. Feathers opened a new realm, connecting land with sky. Amazingly, each stage of feather evolution had its own purpose: insulation, display, camouflage, signaling, and finally flight. None of these functions were extra. Each was a stepping stone allowing life to rise higher. In our imagination, feathered dinosaurs are usually small creatures, quick, nimble, darting through forests like prehistoric birds. But then scientists discovered something that made the world freeze. Even giants once wore feathers. The first discovery of this new chapter did not come from China, but from Russia, the icy Siberian region where time seems frozen underground. There, paleontologists found the fossil of a small dinosaur named Coelendrodromeus zabaikalicus, uncovered at the Coelinda site. What amazed them wasn't the bones, but the incredibly delicate impressions around them. Short, evenly arranged feather-like filaments covering its body. And here came the shock. Coelendrodromeus was not a carnivore, but a plant-eating dinosaur. Before this, feathers were thought to appear only in Theropoda, the meat-eating bird ancestor dinosaurs. But Coelendrodromeus belonged to a completely different group, Ornithischia, the bird-hipped dinosaurs, distant relatives of Triceratops and Stegosaurus. This meant feather-like structures existed not only in meat-eaters, but also in plant-eaters. The fossils at Coelinda were astonishingly preserved. Under a microscope, scientists found several types of filaments. Thin hair-like ones, flattened scale-edged ones, and even triple-branch structures resembling true feathers. This suggests feathers did not evolve just once, but may have appeared across multiple dinosaur lineages. And if both major branches, Theropoda, meat-eaters, and Ornithischia, plant-eaters, once had feathers, then the conclusion is nearly certain. The origin of feathers must be far older. Scientists traced back to the Triassic period, more than 220 million years ago when the earliest dinosaurs appeared. The climate was hot and dry by day, but freezing at night. Many small reptiles likely evolved special skin to retain heat. And perhaps at this stage, the earliest proto-feathers emerged. At first, they may have been tiny keratinous bumps like sensory whiskers or down fuzz. Over tens of millions of years, they branched and transformed into complex feather structures. If this hypothesis is true, feathers were not exclusive to birds or certain dinosaurs. They were a shared inheritance of all dinosaurs. Some giants like Diplodocus or Argentinosaurus may have lost these feathers as they grew, since their massive bodies generated heat efficiently. But in juveniles or colder regions, feathers still offered crucial protection. Imagine it. A colossal dinosaur weighing tens of tons, yet covered in fine down along its neck or back like a light cloak. Not a scaled tank, but a warm, vibrant, colorful creature. This raises an intriguing question. Could almost all dinosaurs have had feathers at some stage? If feathers originated in their shared ancestor, then even species we imagine as bald, like T-Rex, Stegosaurus, or Brachiosaurus, may have had downy fuzz when newly hatched. This is no longer far-fetched. Some fossilized skin from giant dinosaurs shows complex textures combining scales with soft patches. Much like crocodiles and birds today sharing different evolutionary traits from ancient ancestors. From an evolutionary view, feathers were not just an invention for flight, but a biological breakthrough enabling unprecedented adaptation, insulation, display, communication, and ultimately aerial dominance. Although evidence for feathered dinosaurs keeps growing, scientists still do not fully agree. This story, like Earth's evolutionary history, Swan, is still being written. Some researchers believe feathered dinosaurs were exceptions, not the rule. They argue that fossilized feathers appear mainly in extremely special environments, like Liaoning lakes or Siberian ash beds, where conditions for preservation were perfect. Thousands of species in deserts, rainforests, or plains left almost no feather traces. So are we seeing only a tiny slice of the truth? The skeptics claim most dinosaurs were scaled, and only certain evolutionary lines, such as bird ancestors, developed feathers. Their evidence includes skin fossils of large dinosaurs such as Edmontosaurus or Triceratops, which show blocky skin patterns with no hair follicles. If all had feathers, they ask, why not here? But the opposing side argues, absence of evidence is not evidence of absence. They emphasize that soft tissue like feathers is extremely hard to preserve. Not finding feathers does not prove they never existed, only that they were not fossilized. Meanwhile, modern genetic studies point the other way. By comparing the genomes of birds, crocodiles, and reptiles, scientists found that feather-forming genes existed very early, likely in the common ancestor of dinosaurs. A Harvard team even tried activating some feather genes in crocodile embryos and observed follicle-like structures emerging, as if nature could flip a switch that had been off for hundreds of millions of years. This leads many to believe feathers are not unique to birds, but a hidden heritage of all dinosaurs, waiting to be switched on. Yet the deeper question is not just whether feathers existed, but why. Why did feathers evolve in some species and vanish in others? Climate may be the key. Dinosaurs living in cold regions where night temperatures dropped steeply benefited from insulating feathers. Meanwhile, giant tropical species whose bodies generated enormous heat may have shed feathers to stay cool. Some hypotheses suggest certain species lost feathers as a survival strategy. On huge bodies, feathers offered little defense, while smooth skin made it easier to control parasites and save energy. In short, evolution has no right or wrong. It only chooses what fits best at the time. The debate has even spread to art and pop culture. For decades, Hollywood and textbooks portrayed dinosaurs as sleek, gray reptiles. This image became so ingrained that when scientists announced T-Rex may have had feathers, the public reacted strongly. People said, "I don't want to picture a giant dinosaur looking like a giant chicken." But scientific truth sometimes goes against visual comfort. Evolution does not care about aesthetics, only about what works. Interestingly, this debate has brought science closer to the public. Instead of rigid answers, people now see how humans truly explore the world. Through skepticism, experiment, and admitting we do not know everything. A paleontologist once said, "The most beautiful thing about dinosaurs is not that they once existed, but that they still make us argue. It means their story is still alive, and it is true." Beneath every layer of rock and each tiny fossil fragment, we continue searching for clues to the first feathers, evidence linking past and present. Though the debate is unresolved, one thing is clear. Dinosaurs are no longer symbols of giant reptiles, but of transformation. Proof that evolution can rewrite things we once believed were absolute. Thanks to the discovery of Kulindrodromius, we now know that the earliest feathered ancestors of both carnivorous and herbivorous dinosaurs may still be hiding somewhere. Perhaps in rock layers older than the Jurassic. Who knows? Somewhere in the icy lands of Siberia or a distant corner of Earth, fossils still wait to be unearthed, carrying untold secrets about the origins of feathers and the evolution of life itself. The journey to uncover feathered dinosaurs may not be over, but each discovery brings us closer to the truth about our planet's past. If you found this story fascinating, don't forget to like, subscribe, and turn on notifications so you won't miss any of our next adventures.